Hello everyone. In this question it is asked that if e raised to the power sin square x plus sin to the power 4x plus sin to the power 6x up to infinity times ln 2 is a root of the quadratic equation x square minus 9x plus 8 equal to 0, then find the value of cos x upon sin x plus cos x, and the value of x ranges from 0 to pi upon 2. Okay, so first of all, let us focus on the value of x. Okay, so x, if x lies between 0 to pi upon 2, this first of all implies that the value of sin x lies in the first quadrant, right? So the value of sin x is only positive in this area, in this interval. Okay, so sin x lies between 0 and 1, and 1 is excluded because pi by 2 is excluded. Okay, 0 is included, but pi by 2 is excluded. Okay, so sin x lies between 0 and 1. Okay, so this implies that if we square both sides, this implies that sin square x also lies between 0 and 1, where 1 is excluded. So from here we can conclude that the modulus of sin square x is less than 1. Okay, so we take this, we get this conclusion, some modulus of sin square x is less than 1. And this will be very important because in the power of E, we see that it is a infinite GP series. Okay, the series given is sin square x plus sin to the power 4x plus sin to the power 6x, right, to infinity. Okay, so this is a GP series because if we divide the second term sin to the power 4x by sin square x, okay, we get sin square x. And similarly, if we divide the next consecutive term, the third term by second term, we get sin to the power 6x divided by sin to the power 4x, and this is again sin square x, right? So this is a infinite GP series, and the common ratio is sin square x, and this common ratio is less than 1, right? So this GP series, infinite GP series, infinite GP series, infinite GP series is convergent, if the common ratio mod r is less than 1, right? Convergent means that it converges to a specific particular value. Okay, because otherwise it will diverge, and divergent infinite GP series, or any series that is divergent, does not give any particular value. Okay, so for our case, this is a infinite GP series and it is convergent, so it will give a particular value. And the formula for this summation, this is given by a upon 1 minus r, right? And this is most commonly asked in the JEE exams and other exams. Usually they ask this type of infinite series, they ask this convergent infinite GP series. Okay, so in our case, the first term is sin square x, so a is sin square x, and r is again sin square x. Okay, so the value of this sum, particularly this term, is goes to sin square x upon 1 minus sin square x. Okay, so this gives us, this is sin square x, and 1 minus sin square x is cos square x. Okay, so this gives us tan square x. Okay, so this is the value of the sum. Okay, so we have not yet found the value of e raised to the power this sum. Okay, so the summation converges to tan square x. Okay, so therefore e raised to the power, let this sum be s. Okay, so this, then the sum can be written as e raised to the power s times ln2. Okay, so this becomes e raised to the power tan square x times ln2. Okay, and this can be reverted back. See, the power rule is the power rule of logarithm is log of x to the power n to a base a. This is n log x, right? So we are given this RHS, so we can revert back to the LHS. Okay, so I am writing it as, this is ln 2 raised to the power 10 square x. Okay, And another formula that is very commonly used is a raised to the power log x, and if the base is a again, this gives us x. Okay, so in here, in this case, ln is base e. Ln means just log to the base e. Okay, so for this formula, for if the base is e instead of a, this will become e raised to the power ln x. Ln x means log base e, and this will give us x again. Okay, so here this means basically e raised to the power log of 2 to the power 10 square x. Okay, so this will give us 2 to the power 10 square x, right? Okay, so we are given this 2 to the power 10 square x. This is the root of this quadratic equation, x square minus 9x plus 8 equal to 0. Okay, so now the quadratic equation is x square minus 9x plus 8 equal to 0. So if we factorize it, we get x minus 1 times x minus 8 equal to 0. Okay, so the roots, either we get the root is 1 or root is 8. Okay, now we are given that this value, this e to the power this sum is a root of the equation. Okay, so this value converges to 2 to the power 10 square x, right? So this root is 2 to the power 10 square x. Okay, this is equal to 1. So 1 can be written as 2 to the power 0, right? Anything to the power 0 is 1. So since the bases are now same, we can now equate the power. So this will give us 10 square x equal to 0. And since x is in this 0 less than equal to x less than pi by 2, right? So this is in the first quadrant. So for first quadrant, the value of x will be 0. Okay. Similarly, for the other root, 2 raised to the power 10 square x is equal to 8. And this can be written as 2 raised to the power 3. Okay. So again, the bases are now equated. So this implies 10 square x will be equal to 3. And this will implies that x will be equal to, if 10 square x is 3, right? Sorry, not um, not x, sorry, my bad. It is my bad. This will imply first of all that 10x is 0. Okay, 10x is 0, and then it will imply that x is 0. In this case, in this root, this will imply that 10x is root 3. Okay, we are taking the positive root because this x is in the first quadrant. So in the first quadrant, we get only 10. 10 is positive. All trigonometric ratios are positive. Okay, so 10x is positive root 3. Okay, so this will imply that x is pi by 3. Okay, so either x equal to 0 or x equal to pi by 3. Okay, so these are the two values. So for this value, we find the value of what was cos x upon sin x plus cos x. Okay, so this will give cos x plus sin x plus cos x. This will give cos 0 upon sin 0 plus cos 0. Okay, so cos 0 is 1, sin 0 is 0, and cos 0 is 1. So this will give us the value of 1. Okay, so this is one value. For this x equal to pi by 3, we find again the value of cos x plus sin x plus cos x. And this gives us cos of pi upon 3 upon sin pi upon 3 plus cos pi upon 3. Okay, so this gives us cos pi upon 3 is half, right? So this gives us half in the numerator, and the denominator we have root 3 by 2 sin pi by 3, and cos pi by 3 is half again. So if we add the denominators, we get half in the numerator and the whole fraction, and it is divided by root 3 plus 1 upon 2. Okay, so we cancel off the 2's in the denominator of both numerator and denominator of the larger fraction. Okay, so we get 1 upon root 3 plus 1. Okay, so let me rationalize the denominator. So I multiply with the conjugate root 3 minus 1 in both denominator and numerator. Okay, so this gives me, in the numerator we get root 3 minus 1. Okay, and in the denominator it is a plus b into a minus b, so it is root 3 square minus 1 square. So root 3 square is 3 and 3 minus 1 is 3 minus 1 is 2. Okay, so this is another value, half times root 3 minus 1. Okay, so this is for x equal to 0, the value of 1 we get for x equal to 0, and this value we get for x equal to pi upon 3. Okay, so this is the other answer. So we get two values of cos x upon sin x plus cos x, because we get two values of x equal to 0 and x equal to pi upon 3. Okay, so this is it. This is the sum. Okay, we use the given conditions to find this sum, this infinite GP sum, and it is a convergent sum because common ratio is less than 1 due to these restrictions, because x is between 0 to pi upon 2. Okay, if this condition is not given, then this sum is divergent, and for divergent sum we cannot do this, we cannot get any particular value. Okay, so this is it. Okay, thank you.